mergers. So we'll start by talking about the comparative statics within Cournot competition and the benefits from entry of new firms, and how Cournot competition can drive prices to cost, as well as more general lessons about how competition gradually drives prices to cost, including empirical studies of the effects of competition on prices. We'll then discuss mergers in product differentiated industries where products aren't all the same, and in particular the concept of so-called upward pricing pressure. Then we'll talk about how you can estimate the effects that a merger has on consumer welfare, as well as the legal and institutional foundations of merger policy in the United States and other countries, and other common approaches to merger analysis, as well as challenges going forward. And as usual, here we go. The most interesting parts will be sort of what's left out of the analysis so far, so very briefly talk about that. Okay, so what we're interested in today is the effects of increasing competition on the prices and quantities in a Cournot industry. And this is basically a classic comparative static exercise. We're changing the structure of the industry and we're looking at what effects that has. Now, as usual, we're only going to get those effects right if what happens shouldn't. So we're only going to get comparative static effects correct if some condition is satisfied that we studied from equilibrium theory. What's that?
That the condition is the point of equilibrium, which is that there's simultaneous quantity.
So that's definitely correct, but then there's something additional. Remember, when we talked about like equilibrium in product markets, it wasn't just that supply equals demand, but there was something else that we needed if the comparative statics were going to be correct.
I'm not sure.
Well, so we said, does anyone else remember what we need? Who didn't just look at the slide? Oh, okay. It's basically that we need stability of the equilibrium, not just that it is an equilibrium, right? That was the Samuelson's correspondence principle. And that's true here as well. So let's consider the simplest case when there's n identical firms with constant marginal cost. So what is going to be the marginal revenue of an individual firm? This just comes out of last class. Vic, can you tell me what the marginal revenue of an individual firm is again?
We're going to take derivative. It's like price times quantity.
Yeah.
And then it's is that to usually making an effect on it, right? I mean, like,
yeah, so it's just the classic marginal revenue equation that we've been using.
yeah,
So,
price times quantity and then plus the derivative of the quantity. Right.
okay. It's P prime times quantity plus price, right? And so if we then sum this equation over the whole industry, we get that the total quantity, which is the sum of the individual quantities, plus the number of firms times price, is the sort of industry marginal revenue, right? And then marginal cost is constant. So when is this going to be stable? Well, it's going to depend on this thing intersecting the cost curve in the right direction, right? So just like in a normal monopoly, something's an optimum if the marginal revenue crosses from above to below the marginal cost, and in a in a supply and demand equilibrium, if the demand crosses from above to below the supply, that's an equilibrium series. In the same way here, when this crosses from above to below the marginal cost, then that will be in equilibrium. Okay, so when this equation is decreasing in the quantity, then the thing will be stable, and that's the same as saying that, so this is Q times P prime plus P, that's just the monopolist marginal revenue, right? That's the basic marginal revenue equation. Q times P prime plus P. And then we have this additional n minus 1 times P prime added on to this, right? And so if this is less than 0, then we, everything is stable. So notice that P prime is always negative, so that always makes this more satisfied. So if we assume just that the marginal revenue is declining, that's enough to ensure that this thing is negative, and therefore that the cost is over. So we're just going to, for simplicity, assume we face a demand curve which has declining marginal revenue. And then we can do very simple comparative statics. In particular, we can ask what happens when the number of firms increases. And this allows us to determine the effects of competition. So the equilibrium, again, is given by quantity times P prime plus n times price is equal to n times cost, right? Now, n has to be an integer, obviously. There can only be an integer number of firms. But today we're just going to forget about that, just to make things simple, and we're going to take derivatives with respect to n. And we can do that using the implicit function theorem. Alex is not here. Does anyone else want to do that? How would we take the implicit derivative of quantity with respect to the number of firms in this equation? Well, one thing we could just do is we could write this in terms of the marginal revenue, right? So remember that this is the marginal revenue plus n minus 1 times price is equal to n times cost. So if we increase n, that's going to change marginal revenue times the amount that changing the quantity. The quantity changes when the number of firms increases, right? Plus n minus 1 times P prime times the amount the quantity changes when n changes. That comes out of the n minus 1 times P prime term. But then when we increase n, that also increases this, so you get plus P, and then that's equal to C, because C is on the other side. N times C is on the other side. Does that make sense?
Why is it plus P there?
Because it was n minus 1 times P. When you take the derivative with respect to that, use the product rule. One part comes out of the change in P of Q, which is this term, how the quantity changes when the number of people change, times P prime. And then one comes out of the change in N times P, which is this term. Okay. So that is the same as saying that the difference between price and cost, which is just right here, is equal to negative mr prime plus n minus 1 p prime times dq over dn. And so that gives us this equation here. So notice that on the bottom we have exactly this stability condition, right? So just as before, everything is going to be determined by making sure that things are stable, but assuming that that's correct and that's negative, that cancels with the negative sign here, and you get that the change in quantity as the number of firms increases is exactly equal to the markup. And that's positive. Why is that positive? Why is that positive? Rita's not here. Yeah.
Just because, like, for example, you take the extreme, like, monopolist and want to limit its output so it can
Yeah.
charge higher prices.
Yeah.
And that, like, as the market power kind of erodes, that effect lessens.
Yeah, so it's always going to be, this thing is always going to be positive, both because, you know, the price is always above the cost, otherwise the firms would be making losses, and because intuitively, as there's more competition, firms get a lot smaller part of the market, they have less incentive to charge such high prices. So entry here we can also think of as being just like the exogenous competition that we talked about before, right? Because some firm is now coming in and it's producing something, and that's competing with the other firms, and the other firms have to take that as given, right? And so entry and competition is going to increase quantity and lower price whenever price is above cost. And notice that this effect is going to become slower and slower the more firms there are. Because as there are more firms, price goes down towards cost. So the rate at which an increase in the number of firms decreases prices is going to diminish. Right? Okay. So as the number of firms grows large, this means that price is going to have to converge to cost. And according to this equation, it's more or less going to do that exponentially, right? It's sort of going to have this exponential die-off towards cost. And in particular, the change in price when the number of firms change is equal to P prime times the change in the number of the quantity sold with respect to the number of firms, which if we just divide the bottom through by P prime, gives us the following equation. The change in price when the number of firms increases is equal to negative of price minus cost times the pass-through rate over 1 plus n minus 1 times the pass-through rate. So if the pass-through rate is constant, there's just a constant exponential die-off of prices towards cost. So another way to see the equation is that price minus cost is equal to P prime times Q divided by N, right? So the markup term dies off with N, and so as long as P prime Q is finite, right, as long as this term doesn't somehow blow up or something weird happen, as we get towards cost, as N goes to infinity, this has just got to die off. Okay. So a final way to look at this is that we can think about the markup. Remember, we derived this Lerner formula. P minus C over P is equal to 1 over the number of firms times the elasticity of demand. So as long as the elasticity is bounded from above at price equals cost, again, we get convergence. So this is one of the most important results probably the most important result in industrial organization. It's called Cournot's theorem. It says that as the number of competing firms grows arbitrarily large, price converges to marginal cost. And it's both the foundation of all the stuff we did about perfect competition in the beginning of the course, right? This is one reason why we believe that those models are useful in industries where there's a large number of firms. And it's going to be, as we'll see later in the class, the foundation of most antitrust policy, which tries to keep the number of firms large. Now, this was a relatively simple case of Cournot's theorem. We assumed constant marginal cost and all the firms were the same and so forth. But more generally, firms can have nonlinear costs. Demand can satisfy weak irregularity conditions. The only key thing is that as the number of firms gets large, no firm is so persistently better than all the other firms that it stays large in the equilibrium relative to the other firms. Every firm has to become small. And this result fails basically only in silly or perverse cases. So in the Cournot model, competition always and gradually drives prices to cost. But this fundamental intuition is not just true in the Cournot model, it's really true in a much broader range of models, as I want to now try to show. So let's consider the heterogeneous cost per Tran model that we talked about in the last class. So remember that in that model, firms had a distribution of constant marginal cost, CI, and they took as given the prices charged by the other firms in the industry. And this could represent either Bertrand competition, or as we discussed in last class, it's the same as an auction, basically, right? I'm trying to just undercut the next guy. So my optimal price is going to be, and we can prove this more formally than we're going to do here, but it's going to be exactly my expectation of the cost of the second lowest guy, given that I'm the first.